So we talked about various type of morphology and physiology and anatomy in the previous video. What are we going to understand here? The morphology of the cells. Now, what is the morphology of the cell? Is its shapes, right? So the different type of cells have their different morphology. As expected, every cell does not have the similar morphology. Some are compared to the morphology of pavement, that is commerce, and it is stratified, not stratified, but it is something like that. So squamous epithelial, it's is compared to pavement and it has serrated margin. So serrated is like up down irregular patterns, that's the thing, and that serrated helps it to bind, especially whenever we are talking about the human body and these type of things. Then morphology plays a large role, and with the help of morphology, symmetry also plays there. Now, how does symmetry and morphology combine? Symmetry and morphology do combine with the help of regular. So a thing that we talked about in the previous video is why symmetry is necessary. So symmetry is necessary due to it being regular. So regular symmetry is required because it helps in your physiological process, in your bloodstream, your body's maintenance and the supply of everything. So that's why symmetry is required. But with the help of required physiology and everything, we need perfect symmetry. So we were talking about the morphology. So whenever I'm talking about the morphology of amoeba, then I will find that the cell wall is absent, first thing, and the second thing, it is does the work of macrophage, that is amoeboid phagocytic. Now I just said a large word. What is amoeboid phagocytic? It is like extending its arm to catch on the prey. That's the thing. So amoeba does this thing which is called as hunting. As we you can see here, this comes from the small organism to the large and large. Us humans with the size of this big, when we were hunting, then we were still hunting, right? We humans used to hunt, and so does various of large complex organism do right now. But that process started from the simple amoeba, which still to this day does it work. It eats paramecium by extending its amoeboid, that is pseudopodia. It extends that and covers it, and it grabs on the parenchyma, that is your paramecium, and then is releases some type of enzyme on it, which leads to the nutrient being digested outside the body. So that's the thing. It is understandable that amoeba does that work. So its morphology is like that, uneven pattern. The nucleus is eccentric but not regularly, because it has an uneven pattern. What are the chances that it will have nucleus situated there, and nucleus is not like attached to the substratum or something. It can also move due to the motion of the cell. Although the amoeba cannot go into fast speed or cannot suddenly slow down, because they do not have this type of speed, but as humans we can do that, and due to inertia our internal organ would go above our body, but they cannot do that because they are not that fast. But if I flick my hand like this, some amoeba probably did that thing and their nucleus moved. But some cases nucleus is not even present. For the special type of thing, that is our skin, no nucleus is present in this dermal layer because of the constant pressure, rigidity and environmental crisis that it has to face. And due to all these prospect, it loses its nucleus. And but stem cells come here and does the work of the nucleus itself by dividing itself. So nucleus is not required in that thing because stem cell already has nucleus. Thank you.